So this is lecture number 3 AP Chemistry, and we are going to attempt structured questions on moles and molar mass. So first of all, the question is a sample of magnesium weighs 12 grams. Magnesium reacts with oxygen to form magnesium oxide. So first of all, we have to write its equation. When magnesium reacts with O2 in its elemental form, and we know that magnesium is in solid state, oxygen is in gaseous state, and it is going to form magnesium oxide, and it is in solid form. So we need to balance it first. This is 2 mg, and we have to put 2 here as well. Okay, so now we need to find out. He's saying write the formula for calculating the mass using moles and molar mass. So the formula is going to be mole is equal to mass divided by molar mass. And then we have to calculate the number of moles of magnesium. So when we have to calculate the moles of magnesium, then the formula is mole is equal to mass. Mass is 12 grams of magnesium, and its molar mass is going to be 24.30, and moles comes out to be 0.494. Then we have to find out the mole ratio. Using the mole ratio, determine the number of moles of magnesium oxide. So unknown, I'm going to put on the right hand side. Unknown is magnesium oxide and known is magnesium. So first we have to write the moles from the equation. So there are 2 moles of magnesium that are forming 2 moles of magnesium oxide. Then we have the moles of magnesium, which is going to be 0.494, and it is going to be x, and it is going to be cross multiplied, and x comes out to be 0.494. So these are the moles of magnesium oxide. Then we have to calculate the mass, and the mass is, like we know, mole is equal to mass by molar mass. And if we want to find out the mass here, so mass is going to be mole times molar mass, which is 0.494, multiplied by molar mass of magnesium oxide, which is 40.30, and the answer comes out to be 19.90 grams. Okay, so in question number 2, they have given us the mass of water, which is 4.5 gram, and we have to find out the mole. Formula is mole is equal to mass by molar mass, and mass is 4.5 here, and molar mass comes out to be 18.016, and that comes out to be 0.250. Then we need to work out the total number of molecules. So in order to work out the total number of molecules, we know the formula number of molecules, because molecules are particle here, which is equal to mole times Avogadro's number. Mole is 0.250 times Avogadro's number, and that comes out to be 1.51 times 10 raised to power 23. And then we have to find out the total number of hydrogen atoms. We know in water we have 2 hydrogen atoms, okay, and there is only 1 oxygen atom. So in order to find out hydrogen atoms there, I am just going to multiply 2 with 1.51 times 10 raised to power 23 in order to find for hydrogen atoms. So it comes out to be 3.01 times 10 raised to power 23. And in order to find out the number of ratio of oxygen atom to hydrogen atom, so oxygen atom, as it contains only one atom in water, so it is going to be 1.51 times 10 raised to power 23. This is for oxygen. And hydrogen is going to be 3.01 times 10 raised to power 23. The ratio comes out to be 1 and it comes out to be 2. So it becomes 1:2. So in this question, it says that a sample of hydrated salt is heated to remove all the water of crystallization. So first of all, this is an hydrated salt of magnesium sulfate which contains X number of water molecules, and when they are heated, then what happen? It is going to form magnesium sulfate plus X number of water molecules. This is basically hydrated salt, and when the water molecule is removed from there, then it is going to become anhydrous salt. Sorry, basically this is anhydrous salt. So now what happens? They want us to find the mass of water lost. So they have given us the mass of hydrated salt, which is 4.93, and the mass of anhydrous salt, which is 2.41. So in order to calculate the water molecules, what we need to do, we just need to subtract hydrated salt mass minus anhydrous salt mass, which is 2.41. Now the answer comes out to be, that is 2.52. So mass of water is how much? That is 2.52, and that comes out by subtracting hydrated salt with anhydrous salt mass. Now we have to calculate the moles of water. So in order to calculate the moles of water, what we need to do, we are going to do mass by molar mass, and mass is 2.52 there, and molar mass comes out to be 18.016, and that comes out to be 0.140. Then we have to calculate the number of water molecules. So if we want to calculate the number of water molecules, then we must need to find the moles of anhydrous salt as well. So in order to find the moles of anhydrous salt, mass is basically 2.41, and the molar mass of magnesium sulfate is 120.36, and that comes out to be 0.020. So always remember, if we want to find out the number of water molecules in the formula of hydrated salt, the ratio that we are going to use is equal to number of moles of mole of water molecule and the mole of anhydrous salt. This is the formula that we are going to use always. Always remember this formula. So moles of water are here, that are 0.140, and the moles of you can say the anhydrous salt, that is 0.020, and the answer comes out to be 7. So 7 water molecules are present. So it is going to be magnesium sulfate dot 7H2O. So in this question, a student analyzes a sample of white solid known to be a group 1 metal carbonate with the general formula M2CO3. Just remember, like group 1 carbonate, that could be sodium carbonate, and when we heat it, like it is going to form sodium oxide plus carbon dioxide gas would be produced. So in the similar manner, we can write the equation for M2CO3, that is going to be M2O plus CO2. Okay. Write the balance equation for the reaction that causes lime water to turn milky. So what will happen? Calcium hydroxide, which is lime water, and when carbon dioxide gas reacts with it, it is going to form calcium carbonate in solid form plus calcium carbonate, and water is going to form with it. Okay. Then state one observable piece of evidence other than change in lime water that could indicate that a chemical change occurred during the heating. So what happens, as you know, the carbon dioxide gas would be produced out there. So we can see that production of gas bubbles during heating, because it's a thermal decomposition reaction, as we are giving it heat and it tends to decompose. So we can write the production of carbon dioxide gas bubbles during heating. Then use the given mass to calculate the moles of gas produced. So we have to calculate first the mass of a gas, the carbon dioxide gas. And how can we do that? We know that they have given us the mass of the carbonate, which is 0.622, and the mass of oxide is 0.424. And first we can just find the mass of it by subtracting 0.622 minus 0.424, and then we can have the mass of carbon dioxide, that is 0.198. So in order to find the mole of gas carbon dioxide, it is going to be mass is 0.198 divided by its molar mass, which is 44.01, and that comes out to be 0.00450. Then use your answer to part D and balance equation from part A to calculate the molar mass of unknown carbonate. So how can we do that? Like for example, we are given with we need to find the molar mass of unknown carbonate. So first of all, I am given with the mass of the carbonate is going to be 0.622, and I need to see the they have the 1:1. This is 1, this is 1. So it is also going to have the same number of moles as the carbon dioxide gas, because the ratio is 1:1. So mole of the carbonate is also 0.00450, and then we are going to find out the mass and molar mass, sorry. So mole is equal to mass by molar mass, and if we want to find out the molar mass, then how can we do that? Molar mass is equal to mass by mole. So mass is 0.622 and moles are 0.00450, and the answer comes out to be 138.2 gram per mole, which is the unit of molar mass. Now, use your answer to part E to identify the group 1 metal. We can do that because we know M2CO3 has the total molar mass of 138.2. So you can see it is going to be 2m. So I'm going to put it like this, and carbon is going to be 12.01. And then we have oxygen, which is 3 times 16 is equal to 138.2, and 2m is equal to 138.2 minus, we are going to do 12.01 plus 48, and then m comes out to be how much? 39.1 gram per mole, and this is the molar mass of potassium. So potassium is the metal from group 1. So in this question they are saying a student repeats the experiment but accidentally spills some of the solid before weighing it after heating. So what he has done, M2CO3, we know it forms M2O plus CO2. So student spills some of this, he spills it, and then because of it what will happen, carbon dioxide mass would become greater. If its mass would become greater, then definitely M2CO3 moles would become more, because if its mole would be greater, then its mole would definitely be greater. And what are you doing? Like, in order to calculate the molar mass, you are doing mole is equal to mass by molar mass. And when we want to calculate molar mass, we were using formula mass by mole. So when you are going to have greater number of moles, then definitely molar mass will decrease. So molar mass will decrease of M2CO3. Got it? So if the moles, like by increasing the moles of CO2, what will happen? There'll be more moles of M2CO3, and if moles would be greater, we know molar mass and moles are inversely proportional. If that would be greater, then that would be lower. Now, for the next question, they want us to calculate the number of moles in 4.92 gram of aluminium. So first of all, you are going to find out the mole, which is equal to mass by molar mass. Mass is 4.92 and the molar mass is 26.98, and that comes out to be 0.182. Now they are saying if 19.08 gram of chlorine gas is used, determine the limiting reactant, justify your answer. So first of all, what we need to do, we are first going to find the moles of chlorine gas. So first of all, let's find the mole of Cl2 gas, and that comes out to be 19.08 divided by Cl2 is like you have to multiply the molar mass of chlorine with 2, and that comes out to be 70.9, and the final answer is 0.269, which are the moles of Cl2 gas. Now you need to find the limiting reactant, and how you are going to do, like, these are the available moles. These are available moles, and from these available moles I need to find the required moles. So let's see what is going to be the available moles for that, required moles. So we have 0.182, which are the moles of aluminium. And what I'm going to do, like, I'm going to use this table method. So first of all, with the available moles of aluminium, I'm going to find out the required moles of chlorine. So you can see there, from the equation, now 2 moles of aluminium are there, and how many moles of chlorine? are reacting 3 moles of chlorine. I'm using this part for the like from here. So we know these moles of chlorine and moles of chlorine, they would cancel out. And what we need to do, we are going to find out the limiting reactant, the required moles of Cl2. That is going to be 0.182 times with 1.5, and the answer comes out to be 0.273 mole of Cl2. They are required moles. They are required moles. So now you need to do the comparison with the available. You can see the available moles of Cl2 are this one and required are this one. So available are basically less than the required moles. So that means Cl2 is going to be the limiting reactant. Okay, that means Cl2 is going to be the limiting reactant. So Cl2 is limiting reactant here, because its available moles are less than required moles. So it is going to be the limiting reactant, and that would control the amount of product. And they want us to find out the maximum mass of AlCl3, and we know we are going to use limiting reactant for that purpose, because that controls the amount of product here. So now I'm going to use Cl2 here and AlCl3 there, because it's a limiting reactant. So 3 moles of AlCl2, they are reacting to produce 2 moles of AlCl3. So if it is going to be 0.273 and it is going to be X, and X comes out to be like how much? It comes out to be 0. You just need to cross multiply it, and it comes out to be 0.179 moles of AlCl3. So these are the moles, and we need to find the mass. Now we know mole is equal to mass divided by molar mass, and molar mass comes out to be mass, which is how much? That is we just need to find the mass. We need to find the mass here, and for that purpose I'm going to put mass here, and mole is 0.179. I'm going to multiply with the molar mass, and that is 133.30. So the answer comes out to be the answer finally comes out to be 23.9 grams. So this is our final answer. So we need to find out, like they have given us a 50-gram sample of compound that contains 40.0% carbon, 6.7% hydrogen, and 53.3% oxygen by mass. We have to calculate the number of moles of each element in the sample. And how we can do that? We can do that because they want us to find the and what can we do here? We are given with the mass and the percentages. So the best part is going to be for us that first we are going to find the mass of each element. And how can we do that? Just let me explain you this one. First, we have carbon. So in order to find the mass of carbon, carbon is 40%. So 40 divided by 100, the total mass is 50 there. So that comes out to be 20. This is 20 gram of carbon. And for hydrogen, 6.7 divided by 100 times it with 50, and the answer comes out to be 3.35 grams. This is for hydrogen and this is for carbon. And then we have oxygen. So for oxygen we are going to do 53.3 divided by 100 times it with 50, and the answer comes out to be 26.65. So these are the masses that we have found, and now just we need to find the mole. So first of all, mole of carbon is going to be, mass is 20 gram and divided by its molar mass, which is 12.01, and that comes out to be 1.67. Then we need to find the mole of hydrogen, and that is 6.7. No, it's 3.350. It's 3.35 divided by 1.008, and that comes out to be 3.32. And then we have to find the mole of oxygen, which is how much? 26.65 divided by 16, which is its molar mass, and it comes out to be 1.67. So now we have the moles of each one of them. So what we are going to do, I need to find the simplest whole number ratio. So I'm going to put like, this is carbon, this is hydrogen, and this is oxygen. Carbon moles are 1.67, hydrogen is 3.32, and oxygen is 1.67. So I have to divide with the smallest number of mole, and the answer comes out to be 1:2:1. So that is going to be CH2O.